Alright, so find the derivative of this function f of x equals 1 over cube root of x squared plus x plus 1. Can you tell the layers of the function? There is a 1 over cube root. There is also the inner function is what? This polynomial, what? X squared plus x plus 1, right? So for the 1 over cube root of something, how to find the derivative of 1 over cube root? We're not talking about this complicated function. Just 1 over cube root of x derivative. How to do it? No idea? Power rule. See, this example is after the power rule combined with chain rule, right? So power rule. Can we use power rule to do it? What is 1 over cube root of x? Cube root of x can be written by x to the what? 1/3. What is 1 over x to the 1/3? You guys agree with me? 1 over cube root of x equals x to the negative 1/3 power. To compute derivative of this, which rule I'm going to use? Power rule, right? So n is negative 1/3 times by x to the n minus 1. Negative 1/3 minus 1 give us what? Negative 4/3, right? Done.
Can that go on our formula sheet?
What?
Can that go on our formula sheet?
Well, this one, I would say that square root of x, right? This one is a more popular one. This one you just need to memorize, right? So 1 over cube root. Say later if in exam I give you 1 over 4th root. So you have to know, oh, 1 over 4th root of x is 1 over x to the 1/3. It equals x to the negative 1/4. So I change. This is not as a standard, more common use. It's not. So it's more specific. So probably not. But this one is, only square root of x equals derivative equals 1 over 2 times square root of x. So this one you know, if this looks so fancy, the root, it is a negative exponent of x. Okay. Now let's come back to our question. So in order to find the derivative of this function at the first, we should do what? We know 1 over cube root equals what? Negative 1/3 power, because it's here, right? And then what's inside of parentheses? X squared, whatever that. Yes, you're right. So x squared plus x plus 1 to the negative 1/3 power. Alright, so can you tell the two layers of the function? One layer is a power function, right? The other layer is what? So this is what? G of x, right? So differentiate of g of x to the negative 1/3 power. Okay, so let's compute the derivative. Okay, f prime of x equals, combining the power rule. What is power rule? What is g of x to the 1/3 power derivative? It equals what? Negative 1/3 times by g of x to the what? Negative 4/3 power, right? We did it from here, right? What is g of x? X squared plus x plus 1. And times by what? The derivative of what? G of x. I'm going to write it for this step explicitly. Alright, so we need to do this, right? Negative 1/3 x squared plus x plus 1 to the negative 4/3. What is x squared plus x derivative? 2x plus 1. Done. questions? See, it's combining the power rule and with chain rule, right? Alright, let's move on to the next page. We are going to do question C together. Differentiate f. F is defined by a product. A product of something to the fourth power and something to the fifth power. So how do you do this differentiation? This is not just chain rule anymore, okay? Power rule, chain rule anymore. We also have to involve what? Product rule, right? Product rule. So to differentiate f, because this is a product. Do you still remember product rule? Okay. Product rule is telling us differentiate this. Minus 3 to the first power's derivative. I'm going to say derivative times by what? X squared plus x plus 1 to the fifth power. Plus what? Differentiate the second factor and then times by what? The first factor. 2x minus 3 to the first power times by make sure you understand this step, right? By product rule. Okay, this is the product rule. What do we do next? Find the derivative respectively, right? So how do you find the derivative of 2x minus 3 to the fourth power? Is this the power? Yes, it is, right? So to differentiate the power, we use power rule, right? So we should have 4 times by 2x minus 3 to the cube. This is power rule, right? Times by chain rule. What is chain rule? Derivative of what? 2x minus 3. Okay, I don't want to skip step, okay? So I'm going to rewrite like this. This is a power rule combined with chain rule. And then, of course, we're going to multiply by x squared plus x plus 1 to the fifth power. Okay, and then we just copy 2x minus 3 to the fourth power. Okay, differentiate this. Is this the power? Fifth power? Yes. So, by using power rule, 5 times by x squared plus x plus 1 to the fourth power. Don't forget to multiply by what? The derivative of x squared plus x plus 1. Oh.
You go over that again.
To differentiate x squared plus x to the fifth power, we consider this is the inner function g, right? So g to the fifth power, g of x to the fifth power derivative is 5 times g of x to the fourth power, right? But we have to multiply what? The derivative of g, right? Get it?
Yeah.
You do? Alright, so let's check inside of the bracket. 2x minus 3's derivative is what? 2, right? 2. 2 times this 4 give us 8. 2x minus 3 to the cube times by x squared plus x plus 1 to the fifth power. Okay? This 2 times 4 give us 8. Times by 2x minus 3 to the cube. We also have to multiply by this fifth power. What do we do here inside of this bracket? Derivative of this, right? So it's going to be plus 2x minus 3 to the fourth power times 5 times. I'm going to write as 5 in front, okay? x squared plus x plus 1 fourth power. X squared plus x plus 1's derivative give us what? 2x plus what? 1. We're done. Some of you guys may say, oh, this is 2x minus 3 to the cube. 2x minus 3 to the fourth power. Can we combine like terms? Pull the 2x minus 3 cube. This one is the x squared plus x plus 1 to the fourth power. You don't have to, okay? So, I will just leave this answer here, okay? This 5 I wrote in front of this. So, see, this is still this fourth power times by 5 times that, but I just write this down in front. And then this 2x plus 1 comes from the derivative of x squared plus x plus 1, right? Did it?
I was confused where you got the 5 from.
Yeah, the 5 is here.
Okay.
Everybody? So this one is, and it's not easy. It combines about what? Product rule, power rule, and chain rule. A lot. Okay, so
You have to use the product rule first and multiply it, and then simplify it.
because you see, let's look at this order of operations. This function and this function, the relationship between them is not a composite function. It's product. When we use chain rule, it must be what? A composite function. See, something to the fourth power, this fourth power is outer function, this 2x minus 3 is the inner function, okay? When do we use chain rule? Composite function. But if we encounter a function given by product or quotient, we have to use product rule and quotient rule, okay? Alright, so this is this example, okay? And then we have another 3 questions, find the derivatives of the function. You can actually try all of these, okay, I believe so, but I still want to do one question, you know. I'm going to need you to do one question, you try the other. So which one do you want to do, A, B, and C? B? The second one? You want to try the second one? Okay, so, alright, we'll do the second one together, but I want to give you some hint for A and C as well. So for question A, just some hint. Square root of this thing. How many layers function do you want to consider this function is?
Yes, 3.
Square root of this. I would say at least 2 layers, well, I would say 2 layers for now. Outer layer is square root. What is the inner function? You have to use quotient rule when you do the differentiation, okay? Because this is a quotient, okay? So try combining use chain rule and quotient rule for this one. Number C, y equals cotangent sin of theta square. How many layers of the function? 3. Square is a square of what? This is actually cotangent of sin of theta square, okay? So when we talk about something square, yeah, for trig function we write a square here, but you know it is cotangent of sin theta square. So outer layer is what? Square. Middle layer is what? Cotangent. Inner layer is what? Sin. Try this one, okay? Try it, okay? Try it. Question B. Y equals e to the t times sin of 2t. Find the derivative. E to something. Exponential function 1 layer, right? Okay, so I'm going to do it directly, okay? Derivative of y equals e to something's derivative is still e to something, right? Remember the exponential function. So e to the t times sin of 2t. This is a chain rule, okay? Yeah, so derivative of the outer layer. What is the outer layer? Exponential function, natural exponential function. Well, this is already the derivative of e to the t times sin of 2t. Then times by what? T times sin of 2t's derivative. Do you agree with this? Equals e to the t sin of 2t. Let's still copy that. Now you set a parenthesis. What operation do you see? Product, right? T times by sin t. So by using the production, what do we do? Differentiate of t with respect to t give us what? 1 times by sin of 2t, right? And then plus t, we copy that. And then differentiate what? Sin of 2t. Product rule. See whether you're okay with this step or not. We're not done yet, right? So this is just product rule, right? Product rule. Now, let's keep on compute, okay? E to the t sin of 2t times by 1 times sin of 2t sin of what? 2t plus t times sin of 2t. This derivative, we still have to do what? Chain rule, right? Chain rule. So outer layer is same function, right? So same function derivative is what? Cosine of 2t. And times by 2t's derivative is what? 2. Okay, so I write this 2 in front, okay, in front, because I don't want you guys to think this is 2t times 2 give us 4t. No, the sin of 2t is, so cosine of 2t is cosine 2t. This 2 comes from the derivative of 2t. So I write this 2 in front.
I'm a little confused about the difference between the product rule and the chain rule.
See, Simon, sin of 2t's derivative, we're not using product rule because this is not a sin of t times 2t. It is sin of 2t, so it's a composite function. If you have a sin of t times 2t, then this is a product rule. Trig function must have some variable there. This is not a sin of t times 2t. If this is okay, you use product rule. But this is sin of 2t. So it's a composite, not product. So I would say we're done here. No more simplification. You guys?
What do you do with that 2? You just cross it off?
No.
What is where the t is? You squeeze it in the t.
Alright, so I'm going to write it here since that you, okay. So sin of 2t by unit chain rule is going to be cosine of 2t times by what? 2t's derivative, right? Alright, so cosine of 2t is cosine of 2t, right? What is 2t's derivative? Which is 2, right? But I write this 2 in front of the entire product. So that's how we get 2t times cosine of 2t. You guys? So this is cosine of 2t, okay? It's not a cosine of 4t, no, okay? This 2 is double of cosine of 2t, so that's why I read in front. Brittany, you got it?
Yeah.
Okay. Alright, so far we have already done some practice questions, so I would say that let's practice, okay?